This is section 9.5, problem 42. If you read the problem in the book, this is a revenue function that is given to us, and we're asked to find the marginal revenue when production is at 149 units. What that tells you mathematically, if this is your function, you want to find the derivative, r prime of x, and evaluate it when x is 149, or find r prime of 149. That's what the book is really trying to get you to do here. Find r prime of 149. Easy enough to do. The thing that makes this a little bit interesting is the way the function is written. It looks like, if you take the derivative term by term, when you find the derivative of this first term, it looks like you're going to have to use the quotient rule. And that would work, and you could do it that way. I'm going to choose to do something just a little different. I'm going to simplify this just a little bit, and in two ways. This denominator, I could factor a 2 out of each of those terms, and write that as 2 times x plus 1. The 2, I can cancel 2 going to 2 ones into 3,000, 1,500 times. So that's the same thing as 1,500 over x plus 1, but 1,500 over x plus 1, I'm just going to leave it like that. Forgive me. I'm going to write it as 1,500 over x plus 1. There's a reason why I changed my mind. So I did do a little bit of simplifying on the fraction first. Now let's take the derivative of this term by term. And as I take the derivative of this first term, I'm going to have to use the quotient rule. Think of this as being my denominator, g. This as being my numerator, h. And the derivative of a quotient is the derivative of the numerator, but here, since that's a constant term, it's really pretty easy. G prime ends up being 0 times the denominator, x plus 1. Minus okay, there's your g prime times h. Now, the derivative of the numerator. The derivative of x is 1 times your numerator, 1,500. Here's your h prime times g. Whenever you have a rational function and the numerator is a constant term, the quotient rule is very simple to apply. All of this over h squared would be x plus 1 squared. That's my h squared. So I hope that you have your quotient rule written down and you see how I apply each portion of it. And we are going to have to go back and simplify that some, but it will be easy to do. However, that's not all that I have. I'm finding the derivative of r of x. R of x had 3 terms. I found the derivative of the first term, plus the derivative of 80x is just 80. The derivative of a constant times x is the coefficient. And finally, the derivative of a constant term is 0. So let's see, the rest of this work is just going to be simplifying this mess. Get that out of the way for a second. Now, 0 times x plus 1 is going to be 0, minus 1 times 1,500 is going to be negative 1,500 over x plus 1 squared plus 8. So there is my derivative, okay? And that also, by the way, is the marginal revenue function. If this is your revenue function, this is your marginal revenue function. I'm going to erase this intermediate work. We don't need it anymore. Now, remember what I said? The book asks us to find. If they want to know, for this revenue function, what is the marginal revenue if production is currently at 149 items? All they're saying is take the derivative and evaluate it at 149. So plug 149 into this. R prime of 149 will equal negative 1,500 over 149 plus 1. Substitute 149 for x squared plus 80. Use a calculator to simplify that. And what I would do is, right here, add the 149 and the 1 first to get 150. And then key in, on your calculator, key in negative 1,500 divided by 150 raised to the second, or hit your x squared key, plus 80 equals. and you should get 80.06666. And since this is a business problem, dollars and cents rounded off to the nearest penny, it would be $80.07. So when production is at 149 items, your marginal revenue is $80.07. The interpretation of that would be, if you're currently producing 149 items, and if you were to increase production by one item to 150, how much of a difference would that make in your revenue? It would increase your revenue by $80.07.